All right, so this is an extended version of the talk that I gave for the mentorship presentation back in July. I won't talk about the mentorship because Ray just talked about it, but I do want to give a shout out to my mentor, Matt Hall, for being wonderful support. The project that I'm going to talk about here is the one that I started during the mentorship, and since the mentorship has ended, I've continued working on this project. So last fall, I traveled frequently from the north side of Chicago to Hyde Park, which is on the south side, and I would take the red line down to Garfield and transfer to an eastbound 55 bus. I found that I was sometimes waiting a long time for this bus to arrive, sometimes 20 plus minutes. Now, the CTA's bus schedule promised me a bus every 10 minutes. And then after this unfortunate incident where I got caught in the rain and arrived 30 minutes late to this event I was trying to go to, I had really had it with this bus. So what I wanted to know was I getting unlucky? Maybe these wait times were just anomalies. I also wanted to know, can I use data to better time my trips into Hyde Park? Maybe I was traveling at a bad time of day. Perhaps I could find a sweet spot right before rush hour where the frequency of buses is high, but the travel times between stops is low because there isn't rush hour traffic on the road yet. So I did a little bit of thought, some research, and looked into the sort of data that the CTA provides. And it turns out that they don't publish any of the data that I want. So the CTA doesn't publish statistics about which buses tend to be the most or least on time. They don't publish any statistics about bus bunching. They don't publish a historical record of when each bus arrives at each at each stop. The best that I could find was daily ridership statistics that were 6 months old. So the question then is, can I derive the data that I want some other way so that I can answer my question? So after doing a little bit more research, I found a solution, and that is I could collect the location data of all of the 55 Garfield buses using the CTA's bus tracker API and then analyze this data. This is the same API that the bus apps, or the bus tracking apps use to give estimated arrival times. Now, the bus tracker API only makes accessible the current locations of active buses. So I wrote a script in Python that queried the API every 30 seconds and saved the response data. And so I initially ran this script 24/7 for about 2 months, collecting data from the Route 55 Garfield. And in those 2 months, I collected about 900,000 data points, not counting duplicates. And since the mentorship has ended, I am collecting data from 30 other bus routes now, and I have 25 million data points and counting. And so, of course, once we can figure out what to do with the data, we want to use this to benefit the public, not for profit.
Do they not have a rate limit at all?
Yeah, there's a rate limit of 10,000 requests per hour, but every 30 seconds, 24 hours is about 2,500 requests. So, and you can group, you can request 10 buses at once. So that's why I'm able to do 30 at most. I could ask for another API key if I wanted. So let's take a quick look at the raw data. So this is the response from the API. Each object is a different vehicle. So it might be kind of hard to see. But we get information like the route number. So in this case, this is Route 56, which is the Milwaukee bus. We're given the timestamp that the bus reports its location. We're given its latitude and longitude. We're given its PID, or pattern ID. The pattern that the bus is executing is just the sequence of stops that it's visiting. A pattern doesn't necessarily have to be the entire route. It could just be a subset of the route. The PDist, or pattern distance, is the distance in feet that the bus has traveled along the route. And then there's the TA trip ID, which is just an ID that the CTA assigns to each of the bus trips. Now, there's a couple problems that I had to solve. One was the assigned trip IDs aren't unique. So I can't just load this raw data into pandas and immediately sort the data into individual trips. I need to consider the date that the trip took place. I need to consider that the pattern that it's executing, as well as the trip ID that the CTA assigns before I can find a way to uniquely identify each trip. The API, you may have noticed, also doesn't tell us when the buses arrive at or depart from each stop. We only know its position along the route. So what I need to do is interpolate a sort of combined arrival-departure time at each stop. Now, the upside to this is that I don't need to use the GPS coordinates to do this interpolation because we know the distance in feet that the bus is along the route, and the API also provides us with the location of all the bus stops. So now that we have all this raw data, what do I want to do with it? Well, we need to transform it into something useful that will allow us to further transform it into the data that we want. So the goal is to transform this data into a timetable where each row is a single trip, and then each column, more or less, is one of the bus stops along the route. And having the data in the timetable, or as a timetable, is a very powerful form, as I'll show in a moment. It also works very conveniently with Pandas data frames because data frames represent 2D tabular data. So if you're using Pandas in if you're not using Pandas in Jupyter, are you really doing data science? So just a quick shout out to these libraries. I really must emphasize Pandas and Jupyter notebooks are the backbone of this project. Pandas is doing all of my data processing. Well, I'm telling it what to do. It's not doing it for me. And it's taking the timetable data and transforming it into new forms. And Pandas and Jupyter are great because they allow for a truly iterative workflow with the data. So at each step of the data processing, I can quickly plot the data in line using, as Patrick showed, matplotlib or Seaborn, and I can see what the data looks like. And then I can spot maybe non-intuitive or impossible behavior. And if I notice something like that, then I can go back and look at my data processing methods and see, here's a bug. Or here I've made a bad assumption and I should correct it. So what can we derive from this timetable? Well, as I said, this is a very powerful form. There's a lot that we can derive. So during the mentorship, I focused on analyzing the travel times between bus stops and the wait times between buses. So in this example, we can find the travel times between bus stops by taking two columns of the table representing the stops that we're interested in, and then simply subtracting them. And that gives us a time difference between the two. And so that tells us how long it takes to get between the two stops. I also focus on finding the wait times. And to find the wait times, we can take the table. We can more or less, there are some subtleties that I won't get into, but we can more or less find the difference in times between the rows. So for example, if I took this row representing the times that the buses arrived at California, and then took another copy of that row and shifted it up and subtracted the cells, I'd find how long I'd expect to wait for the next bus to arrive. We can also find the number of trips that are dispatched each hour. Basically, in that sort of situation, okay, so for example, bus 101 is dispatched at 8 a.m. from Central Park, whereas bus 234 is dispatched from California at 8:30. So finding the time that the bus was dispatched really amounts to finding the first column that is populated with data. And the way to do this in Pandas is I can take the table, I can transpose the table, and then do a backfill, so fill the missing data upwards, and then just select that top row. And that gives me all the initial departure times for the buses. And then I can resample that data by, let's say, an hour sample and see how many buses were dispatched each hour in my data set. And then I can aggregate that data as I would like and find other things. So I could really have a whole presentation about all these cool tricks that I've learned to do with Pandas, but I can save that for a different time. So there's a lot of other things that we can do as well. We can find the headway distribution using this timetable data. Headway is the time difference between the buses along the route. We can find the deviation from the official schedule. So the CTA does have an official schedule for when it schedules its buses, and I can compare that to my observed data. We could also find the speed of the bus between each stop because we know the times that the bus arrived at each stop, and we know the location of the bus stops as well. So there's a ton that we can do with just this timetable. So we also want to learn from this data. So I had an original question. I was trying to figure out how long should I expect to wait for this bus to come. Well, an easy way to learn from the data is to create a visualization. This makes the data consumable and digestible. And in the words of Mike Bostock, who's one of my heroes, he says, visualization is a means to an end. It's a means to an end. It's a means to an insight. So we're using visualizations to get some sort of insight about our data. But we don't just want these visualizations to be static. We want them to be interactive. And that way, we don't have to make 100 visualizations or plots of different parameters on a certain data set. We can have one plot and then change the parameters with some sort of widgets and watch it update in front of our eyes. This is also beneficial because this gives an end user an opportunity to draw their own conclusions about the data and to explore the data on their own terms. And if we combine a series of visualizations with a narrative and with a purpose, we can create an engaging story for an audience. And depending on the data set that we're using, we can use it to affect public change. So during the mentorship, I previously plotted my data using a library called Bouquet and made a web app in Flask. This turned out to be not very flexible because in order to have Bouquet create interactive data visualizations, I would need a web service that would let me run Python, and a lot of those cost money, and I didn't want to do that. Bouquet was also frustrating to deal with for a number of other reasons, though one good thing is it does integrate well with Jupyter Notebooks. So enter D3.js. So D3.js is a JavaScript library that allows you to build visualizations in your web browser using SVG, HTML, and CSS. There's a pretty steep learning curve to using D3. I didn't really know JavaScript before I started doing this. Yeah, no, even if you do, it's still hard. And so in the past couple of weeks, I've become acquainted with JavaScript and learned lots of its cute and quirky behavior. So the one thing about D3 is that you have to build and define all of your visualizations from scratch. There isn't a build chart method like there is basically in Bouquet. But this makes it a lot more customizable. So let's take a quick look at some of the visualizations that I've made. This screen resolution is awful. Well, I hope you can read that. OK. Well, OK, so I apologize about the. Huh? I just make it clearer.
Clearer? I don't know why. The resolution's.
That's fine.
It looks fine.
OK. So let's try to answer my original question. So here's an example of a visualization. This is a scatter plot of travel times and a scatter plot of wait times for this particular bus. And we get on the bus at the red line. And then I usually get off around Woodlawn. And I traveled on weekdays. And I usually did this around, let's say, 3:30 p.m. So this is the plot of the wait time, and we can see. So we want to focus. So according to this chart, the Garfield bus leaves approximately every 12 minutes from this bus stop at this hour. Well, you might remember that I said that I was waiting sometimes over 20 minutes for this bus to arrive. So it seems as if I was getting a little bit unlucky. During the mentorship, I did do an analysis and found that I was in the 90th percentile of wait times, waiting for 20 minutes. So I was getting unlucky, and I really don't have any reason to be upset with this bus. And we can also see the travel time at this hour is about 12 minutes as well. Now let's take a look at this other visualization. So this is maybe a little bit difficult to see what's going on here. So this is a visualization of bus bunching. So what is bus bunching? If you've ever waited at a bus stop and had two buses appear at the same time, you've experienced bus bunching. And we can identify bus bunching by considering headway. And as I said before, headway is the time difference between two buses. So if there's a small headway between two buses, then there's a bus bunching incident. Now, there's no standard minimum headway in transit literature for what defines bus bunching. So in this plot, I'm showing headways incidents in my data of headway of less than 2 minutes. Also keep in mind that this data was taken over a 53-day period. So for example, if we hover over here, so it's really hard to read, but at Garfield and Ashland, this is for westbound buses, there were 35 bus bunching incidents in my data. So this means a little more than once every other day, there was a bus bunching incident. Now, if we look at this, we might notice some intuitive behavior. So there are more bus bunching incidents in the morning rush hour and in the evening rush hour. That seems to make sense. There also seems to be more between these two stops. So this is between Garfield and St. Louis and Garfield and Ashland. This also makes sense because the CTA has high frequency service between those stops. And since this is a westbound bus and this way's west, we can see that after it gets past the stops, the incidents dissipate because those buses stop running. So that sort of behavior kind of makes sense. Now, there's some really non-intuitive behavior up here. This is the middle of the night. That's 3 a.m., 4 a.m. And there are, let's see, 37 bus bunching incidents. I really don't believe that because at this hour, there should only be one bus running in each direction. So that's something worth investigating and looking at my data about because one of my guesses is that during the night, the 55 bus, so it runs 24 hours. It changes its designation to N55 to stand for nighttime. And I'm wondering if sometimes they report the N55 and the 55 together, even though it's just like one bus. That's one of my guesses. So I'll have to look into that. And then this is just a visualization that I made of the number of buses that are dispatched, broken down by day of week and time of day. And of course, we see some intuitive behavior. There are more buses dispatched during morning and evening rush hour, fewer at night. For some reason, there are about 8 buses dispatched Friday morning, but only 6.6 buses dispatched Tuesday morning. Why? I don't know, but that's something worth figuring out. So, future plans for my project. This project is very much in beta. I need to clean up my code and improve my JavaScript. I'm sure there's a lot of inefficiencies that could be improved. There's probably a better way to store my data than text files. Everything's being stored as CSVs, TSVs, and JSON files. I could probably look into using some sort of database. I'd like to filter out truly bad data. Right now, I'm only filtering out trips that travel less than 10,000 feet, but perhaps there's some other pathological examples. Maybe a bus failed to report its location for a lot of the route, but I'm interpolating the points that it arrived at the stops. That might not be very useful data. I also want to look at which buses tend to be the most and least on time, and I can do that by comparing my observed results with the CTA's official bus schedule. And then I also want to try to build this project around some sort of narrative and some sort of story that'll make it more engaging. So you can find this project on GitHub. Go to spencerchan.github.io/ctabus. If you want to hear some really wonky, quirky stuff about the code that I wrote or the CTA's operations, talk to me afterwards, or find me on Slack, Spencer. And then, so I'm really interested in public transit, as you can probably tell. And I'm really interested, so if you have an interest in public transit, come talk to me. Also, I'm looking for a new job. So if you know someone who's hiring, especially with data science, please let me know. So please clap.